In this video, we're gonna find the volume obtained by rotating y equals 1 and y equals 3 about the x-axis between x equals 1 and x equals 6. These two functions are very easy to draw, and therefore we're gonna do that to get an idea about what's going on. So this is y equals 1, y equals 3, and x equals 1, the region bounded in this case is given by, it's in green. Okay, so this is our region here. When we rotate this region about the x-axis, we see the following. Okay, first we think of this region as, so let's say we have a cylinder that has radius 3. Okay, think of this one as this sheet of paper that we rotate about the x-axis, okay, without thinking about y equals 1. So here, when y equals 3, we get a cylinder. But when we rotate this one, y equals 1, we are rotating this region, and we're gonna obtain a smaller cylinder. Okay. So in this case, this is y equals 1, and this is y equals 3. And we are interested in we don't want to take the whole volume. We're interested in the volume in between the cylinders. Okay. How can we do that? We can do it very easily. Okay. There are many ways. So we integrate. We know how to. We know the formula for the volume of a cylinder. Okay, we know the height here is 6 minus 1, which is 5, and we know the radius is 3. So it's gonna be for the bigger one, it's gonna be pi times 9 times 5, minus the smaller one, which is gonna be 5 times 1 times pi. Okay, but if we do if we use calculus, and especially our formula, here we know A is 1 and B is 6. The issue is that what's AX? AX, we can think of it as this one here, a small sectional area. Okay. Okay. And in this case, the area here is going to be pi 3 squared minus 1 squared, which is 1. This is, but we're going to multiply by some delta x. Think of this one as delta x, this small distance here, or it's here. It's the same one as here. And we sum up. Okay? When we sum up, we get the area. This is a Riemann sum between 1 and 6 of pi 3 squared minus 1 dx. So here, this is just pi because it's constant. 3 squared is 9 minus 1 is 8. So it's 8 times the integral of dx between 1 and 6, which is 5. So we have pi times 8 times 5, which is 40 pi. Our volume in this case is 40 pi. Okay? We get these constants because these functions are constant. Most of the time we think of this one, our AX, as pi times the outer radius minus the inner radius. squared, because we don't want this area in between. So the outer one gives us the whole area. The inner one takes the area inside. So we have only the volume trapped in between. And that's what's happening here. And that's why we use this formula here. So times dx, and after that we sum up to get the whole volume. We can think of this one as summing up these small circles between 1 and 6 to get the whole volume of the solid obtained by rotating these two functions around about their x-axis. Okay, I hope this helps. Thank you very much. And if you have any questions or you see any mistakes, please comment and share and like and subscribe if you want to. Thank you very much, and I wish you all the best. Thank you again.